Okay, so what we're going to do now is do about 13 questions from chapter 13. These are sample exam questions. Okay, so first question is Joe wants to buy an investment home and wants to hold it for 5 years. He wants to earn 5% interest per annum, compounded annually. I'm sure you'll be reading this a little bit slower than myself. You can slow down this video or watch it a few times. So what is the maximum price he should pay for the home if it will sell for 2.5 million? So first thing we do is we draw the timeline diagram and put in our 5 parts of information. Okay, we know the interest rate that he wants to earn is J1 equals 5%, and the time period is 5 years. Then we put in the PV, but PV is what we're looking for. So put a question mark under PV. Payment is 0, meaning there's no activity of any kind happening in the 5 years, and FV is 2.5 million. Now we bring in the calculator, and the calculator comes in. You notice I bring in the calculator after I draw the timeline diagram. I don't need to start touching the calculator. Now I ignore all this information and look at the timeline diagram. But before that, I put in my information that I need to put in, and that is, so let's continue. Okay, so interest rate, 1 compounding period, and 5 for the interest rate. That's my first step at 1 and 2. Now, N, does it need to be converted into months? No, we're talking about J1. 1 is 1 compounding period per year, so 1 is the year, so 5 is what we need to put in. Done. PV is what I'm looking for. Payment is 0. FV is what I have 2,500,000. That's what I'll be selling this home for. And PV comes out to be 1,958,000. So I think the answer is number A. Done. Okay, let's take a look at question 2. Joe got an interest-only loan in the amount of 925,000. The interest rate charged on the loan is 7.5% per annum, compounded semi-annually. Right away, you know that's J2. J2 equals 7.5. With semi-annual payments means payments are going to be happening every 6 months. That really doesn't need to be there. If the term of the loan is 2 years, what amount will be due every 6 months and the last payment after 2 years? So timeline diagram, put in my interest rates, J2 7.5, time is 2 years, so those are 4 semi-annual periods. 925 is my loan, and be very careful, FE is not given to you. FE is 925 with a negative. So now these are my choices. Let's bring in the calculator and clear everything on the calculator. There's clear. First thing, put in my compounding periods, 2 and 9 for the nominal interest rate. Done. N is for interest-only loans. Sometimes they don't give you N. I like to just put in 1 for N. It doesn't matter. I can put in 4 for N. It doesn't matter. It'll be the same answer. PV is 925. FE is same 925 with a negative, and payment comes out to be 41,000. 41,000 every 6 months. 41,000. Okay. Now, so let's see if I change N to a 1. Is that the same? Yes. Change N to a 36. Same answer. Okay. So we don't have a 41,000 here. Okay, the answer is 41,625. And what will be the last payment? Last payment will be 925 plus 925,000. And that's 966,000. Let me do the interest only again for a second. 2 for the compounding, 7.5 for the nominal, N, I'm going to use 1 for N. PV is 925. FV is also 925 with a negative, and the payment comes out to be 34. Sorry, I did make a mistake on the first time. So the answer is 34,687, and last payment will be add 925 to this number, 959. So it is answer A. So for every 6 months, 34,000. Last payment is 34,000 plus the 925. So this is the first answer. Example 3, another interest-only loan, 925. And this time the interest rate charged on the loan is not 7.5 with semi. What amount will be due every 6 months? And if it's a loan of 5 years, there is no difference in this question from the last question. Okay, so again, timeline diagram. It doesn't make any difference if it's for 5 years or for 2 years. Okay, the answer will be the same, 34,000 and the 959. Okay, interest accruing loan, very important. Interest accruing loan of 150 was started 10 years ago, or with a term of 10 years. Interest rate of 4.5, compounded monthly. Calculate the amount. So remember, interest accruing loan is where there's no payments of interest or principal paid in this time period. So PV is your 150. Let's put the interest rates here. Interest rate J12 equals 4.5%. Time is 10 years. In this interest accruing loan, this is very important. The time period is very, very important. I'll show you in a second. Loan is PV 150. For interest accruing, there's no payments being made, or no payments are made. It's legally allowed to not make any payments. And we're looking for FV. So these are my choices. Let's bring in the calculator and clear everything on the calculator. Put in the interest rate first, 12 for the compounding periods, and 4.5 for the interest rate. Done. N is 120. We're talking months, so 120 months. 10 years is 120 months. PV is 150,000. 0 for payment, and my FV comes out to be 235,000. So that's my answer right there. Now, if I change my time to, let's say, 12 years, 12 times 12 is 144. This number will be different. 144 for N, and my FV is 257. If I change my N to 1 year, let's say 1 year is 12 months, my FE is totally different. If I change this to N equal to 1, meaning 1 month, and then my FE is different again. Okay, so everything is dependent upon N and the PV and the interest rate. In an interest only loan, N does not make any difference. Continue. So that's our answer. Okay, question number 5. Interest accruing loan. What do we know about an interest accruing loan? No payments during the term. Okay, legally allowed not to make any payments. Normally, interest only loan, we make the interest payment. Here we make $0 of payment. Started 15 years ago, and interest rate of J12 4.5. Calculate the amount at the end of 15 years. So first thing we do is timeline diagram. It put the interest rate on the top and then time here. Now we're going to put in the PV. PV is 150,000, and the payment is 0. That's interest accruing loan, 0 for payment, and we're looking for FV. So then these are the choices. We bring in the calculator, and the calculator, we clear everything on the calculator. First thing we're going to do is put the interest rate, 12 for the compounding periods per year, and 4.5 for the interest rate, nominal interest rate. N is 15 years, so 15 times 12, 180. I use my regular calculator to do the arithmetic. Okay, and N is 180, and this has been done. PV is $150,000. 0 for payment, and FV is 294. That's number 1 is my answer. let's go back just for a second. Okay. Now, which statements are true? Is this a true statement? IM of 2%, is that same as J12 of 24? Yes, that's how you get from IM to J, you multiply by 12. That's a true statement. Okay, a periodic rate, daily rate, how do we get from daily rate to a J365? You multiply by 365. When you multiply these two, yes, you do get 9.125. Semi-annual periodic rate of 2.5. How do you get J2? You multiply by 2, you would get 5%. That's a true statement. A quarterly rate of 3.25, how do we make that into a J4? You multiply by 4, and that will get you J4. That's a true statement. Okay, question number 7. John earns 10 cents for each candy box he sells, and he sells an average of 500 boxes per week. The savings rate is J52 equals 5%. How much money will John have at the end of 1 year? Right away, timeline diagram. But before that, let's just figure out what's 10 cents times 500. That's $50 every week that he's saving. Okay, so interest rate J52 equals 5%. Time period 1 year. We're going to think weeks. So 1 times 52 is 52 weeks. Now John has no savings now, but he is saving $50 every week. $50 minus negative because he's putting that into the bank, and we're looking for FV. Then the choices are here, and we bring in the calculator, and we clear the calculator, and we are going to put in our compounding periods first, 52 for the compounding periods, and 5 for the nominal interest rate. N is in weeks. 1 year is 52 weeks. Done. PV is 0. Payments is $50 out of our pocket every week to the bank. And at the end, we will have $2,664. Okay, question number 8. John will save $25 at the end of every week. How much money will John have accumulated by the end of 7th year if interest rate earned is J52 equals 6%? So timeline diagram, put in our interest rate and put in the time period. Time period is 7 years. So 52 weeks per year, 7 times 52, 364 weeks. So what are we looking for? Do we have PV? Well, PV is 0 because he's got no money savings at the start. But he has $25 every week, and we're looking for FV. So here's the choices. We're going to bring our calculator, and the calculator needs to be cleared up. And first thing we're going to do is put in the interest rate. 52 for the compounding periods, 6 for the nominal interest rate. Done. N, 364 weeks, 364. Done. PV is 0. Payments, $25 every week out of our pocket. That means negative. And press FV. $11,301 is what we will have in our bank account. That is the correct answer. Let's do question number 9. John received $250 as a gift and will deposit it into the bank. He will also save $25 at the end of every week. How much money will John have accumulated by the end of the 7th year if he's earning this much, J52? So timeline diagram. Interest rate is J52 equals 6%. Again, time period is 7 years, which is 364 weeks. Do we have a PV? Yes, John received $250 as a gift, and he took it to the bank. So negative for 250. Okay. Also, he's going to save $25, which is also negative. So he's taking this to the bank, he's taking this to the bank, and there's going to be money coming from the bank this way. That means this answer is going to be a positive number. And we're looking for FV. So here's the choices. Let's bring in the calculator. clear all. First put in your interest rate, 52 compounding periods, and 6% nominal rate per annum. Done. N is 364. Good. PV is $250 with a negative is my PV, and every week I'm saving $25. That counts as a payment to the bank, and at the end I will have $11,681. Great. Let's go to the next question. Question number 10. John got $500 from his dad as a gift. He wants to use the money in 2 years to pay $1,000 for a helmet. John has deposited the money in a savings account bearing a periodic interest rate of 0.5% per month. That's going to be a J12. You take 0.5 and multiply by 12, and that gets you J12 equals 6%. That's what we're going to use. Will John have enough money to pay for the helmet in 2 years? If he will not have enough money, how long will it take John to save to get to the $1,000? First thing, timeline diagram, put in the information we have. Okay, J12 equals 6%, and it's 2 years. We want to know, does he have enough money in 2 years? How much money does he have now? He deposited $500. Negative. I put negative because he deposits $500. Every week or he doesn't have any more money to deposit. And we want to know, does he have $1,000? Now this is the tricky part. We do not put FE equals to $1,000. We find what FE is. Okay, these are the choices. Okay, so bring in the calculator. We're not going to put in FE equals to 1,000. We're going to find the FE, and that FE is how much money he will have. So 12 is for the compounding periods, and 6 is the nominal interest rate. N is 24 months. PV is $500. 0 for the payment. This number here is how much money he will have. He will have $563 after 2 years. No, he will not have enough money to buy the helmet. So how much is he short by? He's short by, from 563, you subtract 1,000, he's short by 436. So this is the right answer. And the other part of the question is, how long before he can buy the helmet? Let's bring the calculator back. To do that question, what we need to do is put 1,000 here and find N. So let's do that. 12 for the compounding period. 6 for the interest rate. N is what we're looking for. If we're looking for how long before he will have the $1,000. So N is what we're looking for. Interest rate we've done. PV is $500. 0 for payment. And he wants to have $1,000 afterwards. How long? N is how long. It'll take him 138 months, which is, if we divide by 12, is approximately 11 and almost 12 years. Great. Okay, what will be the second monthly payment of an interest-only loan of $155, and the interest rate is 0.6% per month? How do we get that to J? We multiply by 12. 0.6 times 12. Okay, so timeline diagram, put our interest rate, 0.6 times 12 gives me 7.2%. I know the time isn't given. I'm just going to use N equals to 1. Okay, loan is 155. Payment is what we're looking for. Here for FE, we have to put in negative 155 because in an interest-only loan, whatever you borrow is the same amount you have to return. This negative means you have to return it. This 155 positive means you got it. So because we're just going to be making payments of interest, these two numbers are exact same but opposite in signs. So let's have the choices. These are the choices. Let's bring our calculator, clear the calculator, and first thing is the 12 compounding periods and 7.2 for the interest rate. N is any time, just put 1 for N for now. I'll show you, even if I use different N values, the answer is going to be the same. PV is 155. And negative for the FV and payment, $930. That's my right answer. Okay. If I change N to a 2, no change in answer. Third payment, second payment, it doesn't matter. It's the same amount. Payment number 6, if it goes on for that long, the payment is the same amount, answer. Okay, so continue. 930 is the payment per month for all payments. It can go on forever, or it can be as short as 1 month long. An investment that will produce 150 in 60 months. What is the investment worth, rounded to the nearest $10, if you want to earn 4% per annum compounded monthly? So this is J12 equal 4%. So first thing, timeline diagram, J12 equals 4%, and is 60 months. Do we know PV that will produce 150? That will produce, that goes here. Okay, we're looking for PV. What investment will produce 150? That means your FV is 150. Okay, so we've got our timeline diagram. These are the choices. Then we bring in the calculator and clear everything on the calculator. And first thing is your compounding periods, 12 compounding periods, and 4 for the nominal interest rate. Done. N is 60 months. Okay. The only time N is not important is when we're doing interest-only loans. All other times, N is very, very important. N is done. PV is what we're looking for. Payment is 0. FV is 150. And PV comes out to be 122. This is the right answer. And to the nearest $10, that would mean $850. It wouldn't be 851. Last question, question number 13. What is the value of a $175,000 investment after 36 months? You notice it's 175 we start with, and what is it worth after 36 months? So we're looking for FV. So PV is given this time. Interest rate's there. PV is 175. Payment is 0. We're looking for FV. And these are the choices. And we bring in the calculator and clear everything on the calculator. And the first thing we're going to do is put in the compounding period is 12. And interest rate is 3. Time period is 3 years, which is 36 months. Interest rate's done. PV is 175. Oh, a bit too much, so I can use a back arrow. PV. Payment is 0. And FV comes out to be 191. I look at the answer to the nearest dollar. That would be 459. I believe D is the answer. Good. Oh, one more question. Question number 14. What is the value of $175,000 invested after 36 months, rounded to the nearest $10 if the interest rate is J12 equals 3%? Okay, so we have our interest rate, $175,000 for the PV, payment 0. We're looking for FV. These are the choices. Our calculator comes back, and this time we are going to figure out that if we use compounding 12 and 3% for the interest rate, N is 36 months, PV is 175, 0 for the payment, and the FV comes out to be 191,400, and to the nearest $10 would be $460. I believe the answer is the last one.